Okay, hi everyone. I'm going to go through the EPMATH234 mock final examination number 2. So let's get into it. So the gradient of the line with that equation is, well, I mean we could sketch it, but let's not. All I need to find the gradient of a line is if we can view it in the form y equals mx plus b, then I know that the m will be my gradient, and for trivia's sake, the b will be my y-intercept. So this line is almost in that form. The only thing that's not in y equals form is there's a 3 here. It's times in the y. So what I'm going to do is divide both sides by 3. That means every term is going to get divided by 3. 3y on 3 got rid of the 3 equals 2x on 3 plus 12 on 3 is a plus 4. So the question wanted the y-intercept. I'd say, well, it's plus 4. But clearly the question here just wants the gradient. The gradient is what's multiplying the x, which in this case is a 2/3. So there it is, A. Next one, which of the following points lies on the line with that equation? Well, all equations are relationships between x and y. So I can just chuck in the x value in these coordinates and see what y goes with it. Is it really 9? Is it really -1? And so on. Let's just chuck in x equals 2, because we know all pairs of coordinates are x, y. If x equals 2, that will give me y equals 2 times 2, which is 4, minus 5, which is -1. I can see it's not that one. There it is. I can confirm that the others fail. They should, or else it's a pretty bad question. Put in a -2. 2 times -2 is -4, minus 5 is -9. So it doesn't, -2 doesn't go with 1, it goes with -9. What about -1? 2 times -1 is -2, minus 5 is -7. No, the only one that works for the x and y in that equation is B. Great. Next one, what's the gradient of the line sketched below? Well, obviously it's a positive gradient. Here's me walking along it from left to right. I'm going up, so it's a positive gradient. It's not A, it's not D. The only decision we've really got to make is which is vertical and which is horizontal. You can see my vertical rise, I'm going up 8. My horizontal run is I'm going across 4. They're the two things I'm doing. So my gradient is equal to rise over run, which is 8 over 4. It's just a 2 gradient. And again, clearly it's positive. Oop. Next page. Which of the following is a graph of the line y equals 6 minus 2x? Well, been a bit tricky by not putting it straight into y equals mx plus b format. But as long as you know that everything owns the sign that's left, I've got a positive 6 here. So I've got a plus 6 and I've got a minus 2x. It doesn't matter whether I write on the left or right. Those two things are the same thing. I've still got a plus 6, I've still got a minus 2x. So clearly my gradient is -2, so it's not a positive gradient. They're gone. Gradient is -2, well, which one of these has a gradient -2? 6 on 3, that's 2, and yes, it's negative. 6 on 2, that's 3, and it's negative. They both have the correct y-intercept, but clearly the one B is the only one with the gradient of -2. Okay, if I do it manually, I'd say the vertical rise over horizontal run, well, it's actually, I'm going from here to here, it's gone down 6 over a run of 3. There's my working out to show that a minus on a plus is a minus and 6 on 3 is 2. Yep. What's the equation of the line through that point parallel to the x-axis? I'm going to give myself just a little bit of a sketch here. The point 2 minus 3, here's 2 and here's -3. That's a point. A lot of people do this and then try and join this point with this point. No, it's just a single point of x is 2 and y is -3. Parallel to the x-axis, well, this is the x-axis, so it's going horizontally like this. And from the notes, we've already seen that gradients of horizontal lines are 0, and they're all called y equals. Whatever the y-intercept is, it's y equals -3. Just to further justify that, instead of just referring to the notes, I can say, well, y equals mx plus b. I know the y-intercept is a -3, I can see that. I know the gradient is 0 because it's a flat gradient. So y equals 0 x minus 3. What's 0 times x? Nothing. Y equals -3 is its equation. So I got B. Just checking, I'll put the letter in the box. I did. Okay. A straight line was graph using the following value of tables. Well, I can see, I mean, just by definition, we learned at one stage that when x equals 0, you'll find your y-intercept. And when y equals 0, you'll find your x-intercept. So you can see they're staring at us. Or you might want to visualize it and say, I don't really care about the other dots. When x is 0, y is minus 6. X is 0 means don't go horizontal anywhere, but y is minus 6. Clearly that's a y-intercept. It's touching the y-axis. The other one is a point when x is 2. Okay, I'm over here at 2, y is 0. They're the x and y-intercepts. So we've got x-intercept as 2. Yep, and y-intercept is minus 6. Yep, C. Give us question 7. Which of the following is the correct equation for the line shown? As soon as it says a correct equation, I'm thinking y equals mx plus b. But let's get at it early. It's not a y-axis. It's an m-axis. It's not a x-axis. It's a t-axis. So it's going to be, it's not c or d. Okay, it's m equals. The gradient of this line is a negative. And what's it done? This side is 70, it's gone down 70, over this side is 35. So it's a minus and a 70 on a 35. Well, that's 2. There's two 35s and 70, so the gradient's minus 2, and the y-intercept, or m-intercept in this case, is a plus 70. So I just wanted the one that, yeah, it has a plus 70 y-intercept and minus 2 gradient, and it has to be B. I can rule out A because A says it's got a positive gradient. Definitely doesn't have that. So even just by elimination, I got to B fairly quickly. Let's set A equals that and B equals that. What's set A intersection B? We have to know that upside down U thing is an intersection, which just means what have they both got in common? So it's not union, it's intersection. What have they both got? Oh, they've both got a 0. They've both got a 2. They've both got a 4. They don't both have a 6. 0, 2, 4. Here it is, B. Looks like if in doubt, go B. 9. Let the universal set U equals from 0 to 10. So that means in this question, the only numbers that exist are from 0 to 10. Set C is 0, 5, 10. Set D is 0, 2, 4, 6, 8, 10. Find set C union D dash. Remember that dash just means complement. In other words, that's the union between C and not D. D dash means not D. So let's just look at it. C is defined here. I'm just going to define D dash here. D dash is not D. It's everything that's in the universal set that's not D. So it's not 0, 2, 4, 6, 8, 10. 0, 2, 4, 6, 8, 10. It's everything else, which is 1, 3, 5, 7, 9. So D dash is 1, 3, 5, 7, 9. What's the union between C, which is all this stuff, and D, which is all this stuff? Well, we just put them all together. Union means I don't care whether you occur once or twice, just we're all in the one union. So I need a 0 and a 1 and a 3 and a 5. Clearly my head is being drawn towards C. Let's check. 0, 1, 3, 5, a 7, a 9, and a 10. 7, 9, 10. Yep, there it was. 10, a pair of standard dice, each with faces numbered 1 to 6 are rolled. Yep, the chance of scoring 2 6s is best described as. Well, I mean, good luck. The chance of scoring 1 6 is 1 in 6. There are 6 options, and a 6 is one of them. The chance of doing it again is still 1 6, but the chance of doing both, that and that's a times. It's just like a tree diagram. I could have had 1, 2, 3, 4, 5, 6 options out here and 6 options out here. And you can see what would I have gotten? I would have had a 1 in 6 chance times a 1 in 6 chance, which is 1 in 36. Or you might also see that I would have had 36 outcomes, and yeah, it would have been one of the outcomes. So that's the numbers side of it. Is 1 in 36 probable? No. Even chance? No, that's a half. Improbable? Yeah. Pretty unlikely. It's improbable. 1 in 36 chance. It's not impossible. Just improbable. Don't go ahead. After 12 rolls of a homemade die, I had rolled a 4 3 times using this experimental probability. What experimental probability? Well, experimental probability is, I'll just write EP. It's the number of times it happened. Well, it happened 3 times out of the number of times I did the experiment. So what happened with this dodgy homemade die? 3 out of 12 times it came up as a 4. So experimental probability of getting a 4 was 3 out of 12, which I can simplify to 1 on 4. You don't have to simplify these things, but I know I like it. I've got a 1 in 4 chance. of getting a 4. So if I've got a 1 in 4 chance and I'm going to do it 60 times, I would expect a quarter of that time to get 4s. And a quarter of 60 is 15. Use the formula if you want. Expectation is the number of times you do something times the probability. The number of times I'm doing it is 60 and the probability is a quarter. Again, it's what I said. What's 60 times a quarter? 15. 12. On a television game show, there are 9 squares shown. Behind 2 of the squares, there is a cash amount. Behind every other square, there is a prize. 2 of the squares have already been turned over. What's the probability of getting a cash amount next? Well, there's only 2 squares that have a cash amount. So here's one of them already gone. There's only 1 square left with a cash amount. That's already gone. That's already been revealed to be a prize. Every other one is a prize. So there's only 1 cash amount still unrevealed out of how many? 1, 2, 3, 4, 5, 6, 7. So there's 7 options left and only one of them has cash. So cash amount next is 1 in 7. Okay, we've got a tree diagram drawn for us already. Head, tail, head, tail, head, tail. All looks good. First coin, second coin, third coin. Okay, shows all possible outcomes of tossing 3 coins. They're probably getting 1 head and 2 tails. Well, it didn't say 1 head and then 2 tails. That would be 1 head, 2 tails. 1 head, 2 tails would be this option. Head, tail, tail. But it didn't give an order. It just said 1 head and 2 tails in any order. Well, here's 1 head and 2 tails. I'll write them all out. Head, head, head. Head, head, tail. Head, tail, head. Head, tail, tail. Tail, head, head. Tail, head, tail. You could write neither, David. Tail, tail, head. Tail, tail, tail. How many of them have 1 head and 2 tails? 1 head, 2 tails. 1 head, 2 tails. 1 head, 2 tails. 3 out of all 8. They're all equally likely as each other, all these 8 options, because there's no probabilities on the arms. It's not a weighted tree diagram. It's just each branch is 50-50. So 3 out of my 8 options. If 3 coins are tossed, so we can use the previous diagram, the probability of getting at 1 most tail. Okay, at most 1 tail. At most 1 tail. Just think, at most 1 tail means you can get a tail, but no more. Okay, so it means no tails is fine, 1 tail is fine, but don't venture into 2 or 3 tails. So no tails would be head, head, head. 1 tail is here, 1 tail is here, 1 tail is here. The rest all have 2 tails or 3 tails. 4 out of 8. That's a half. A newsagent in town sells a local morning paper and an evening paper. A survey of the people in town is conducted to study their buying habits. Results are shown below. Good thing to note here is all of these 4 categories are mutually exclusive. We don't have overlap. 25 people bought only the morning paper, 15 bought only the evening paper, 40 got both and 70 got neither. There's no one person that could be in 2 categories. You can't buy neither and both. You can't buy both and buy the morning paper only. They're 4 unique categories. So I'm confident these are the people from the survey. So how many people were surveyed? 25 and 15 is 40, and 40 is 80, and 70. There's 150 people in this survey. So a person from town is selected at random, okay? Out of these 100, it's a small town. A survey of the people in town. A person from the town is selected at random. That's actually quite badly worded. We should say a person from the survey is selected at random, okay? What's the probability that this person buys a morning paper? Well, these people bought a morning paper, and the people who got both bought the morning paper. So 25 people got only morning, 40 got both, so that's 65 in total. Looks like it's got to be simplified down. How many 5s in that? There's 1 with 1 left over, 3. How many 5s are in that? 13 on 30? Yeah, we got it. 45 red cards, 30 blue cards, and 15 yellow cards all mixed together. What's the probability of selecting a random card and it being yellow? Well, how many cards have I got? 45 and 30 and 15. Well, that's 90 cards. How many of them are yellow? Well, there are 15 yellow. So 15 on 90. Well, how many 15s are in 90? 2 15s in 30, hence 4 15s in 60, hence 6 15s in 90. There's 1 15 there. We've got calculators, but there it is. 1 in 6 chance. I have 2 red cards and 3 blue cards all mixed together. Okay, I've only got 5 cards. What's the probability of selecting 2 cards at random without replacement and getting at least 1 blue card? Now this one's a bit trickier because, well, I mean we could work out the answer to all of these. What I'm doing here is saying, let's think of what it means to get at least 1 blue card. That means at least 1 blue card could be a blue then a red, it could be a red then a blue, or it could be a blue then a blue. They're the 3 things that satisfy getting at least 1 blue card. So I can work all of them out and add them up. Or I can think the only thing that fails, that doesn't satisfy the question, is 2 reds. So if I just do 1 minus the probability of 2 reds, that will be the sum of these 3 options. So if you want to just do these 3 options and sum them up, it'll work, but you'll have to work out the answers, which one of the answers of one of these options is equal to this. Or you can see, it's probably this, isn't it? That's the way I've done it. So what's the probability of getting 2 reds? Well, there's only 5 cards and 2 reds. There's 2 in 5 cards are red, and if I don't replace it, now there's only 1 red card and only 4 cards total. That's this. 1 minus 2 reds is C. C's the answer. That's the probability of 1 minus 2 reds, which is equal to a blue red, red blue, or blue blue. Done. 18. When playing mini golf, the probability is that a certain hole of Amy and Billy getting a hole in 1 and 1/6 and 1/9 respectively. Amy's got a 1 in 6 chance, Billy's got a 1 in 9 chance. The probability on this hole, Amy gets a hole in 1, which is 1 in 6, and Billy doesn't. Well, if you've got a 1 in 9 chance is of getting a hole in 1, the remainder is not getting a hole in 1. 1 minus a 9th is 8/9. So the probability of Amy getting it is a 6th. Probability not getting it is likely 8/9. And it said and Billy doesn't. We know that when I'm trying to do the probability of this and probability of this, like rolling 2 6s before, and is the times. What do I get? 1 times 8 on the top and 6 9s are 54 on the bottom. It's there unsimplified already. Great. In a survey of open foundation students, 54% own a car, 38% own a bicycle, and 40% own neither. So we want to find the overlap, the number that own both. There's a formula we could use. I'm a bit of a Venn diagram person here. Yeah, I'd go Venn diagram because we've got this neither. Let's just make a nice old Venn diagram. I'll do it here. Now there's 2 categories. What have we got? Car people and bicycle people, whether they own it or not. Whether they use it, that's different. 54% own a car, but I don't know where to spread my 54, but I know the C circle will add up to 54. 38% own a bike, same story, I don't know where to put it yet. 40% own neither. Now, it might be confusing doing these as percentages. Think of it if you want, pretend there's 100 people in the survey. Okay, well, 40% means 40 people. I'm just going to do this without bothering to write the percent thing. So it's like I'm assuming there's 100 people in the survey, so 40 people said they own neither, 40 are out here. Now, how many people do I have to fit in here? Clearly it's 60. If I'm only talking about, it's got to add up to 100%, or I'm pretending there's 100 people, the C and B circle add up to 60. But what do the percentages add up to? 54 and 38. 54 for the car and 38 for the bike. If I add them up, that means like 92 people. Again, I'm just assuming that 100 people were in this survey. 92 people own a car and own a bicycle in those categories, but it can only fit 60. And we've done this before. What's the gap between 92 and 60? 32 people must have been double counted. There must be 32 people that own a car and 32 people that also own a bicycle. That's where the 32 comes into here. Just to complete the Venn diagram for the fun of it, I can already see my answer is there, B. But the C was 54, so if that's 32, 22 here makes 54. The B was 38, so if 32 is already there, the 6 is there. Let's just confirm, 40 plus 22 is 62, plus 32 is 94, plus 6 is 100. Everything adds up correctly, and 32%, 32 out of my 100, and both. The mean, well, remember, don't just pretend there's a 1, a 2, a 3, and a 4. Because there's 22 ones, there's 2 2s, there's 8 3s, and there's 7 4s. There are not just 4 scores here. The total of the frequency column is how many scores I've got. 22 and 8 is 30, plus 7 2 is 39. There are 39 scores here. What do they add up to? Well, not just the sum of the score column, I do an FX column. 22 ones makes 22. 2 twos makes 4. 8 threes makes 24. And 7 fours make 28. So if I add these up, the FX column will tell me what's the sum of all the scores I've got. Well, I've got 2 and 8 is 10 plus 8, so it's 18. 2, 4, 6, 7. So the mean of this set of scores is the sum of all scores, sum of the FX column, over the sum of the F column. In other words, 78 over 39. 2 39s make 78, so it's a good one. 2. The mean is 2. I agree with that. The mean is definitely 2. Great. Page down. A small survey was conducted to estimate how many students travel to uni by car. Results are shown below. So let's just make sure we understand the results. And the results are saying that the number of students in each car, 1. There were 18 cars with only 1 person in it. There were 2 cars with there were 10 cars with 2 people in it. Not clowns. There are 2 cars with 3 in it, and there was 1 car with 4 in it. So how many students do we observe travelling to university by car in this survey? Well, 18 cars with only 1 in it, that's 18 people. 10 cars with 2 in it, that's 20 people came by car. 2 cars with 3 in it, so that's 6 people. And 1 car with 4 in it. There's all the people that came to university by car in this survey. So I've got 18, 2, 3, 4, 48 people. Yep. Okay, bit of data. Following table shows the quiz results out of 5. So 4 people got 0, 6 got 1, so on up to only 1 person got 5. We're going to ask for the median, the mode, and the range. That's it. Well, no one's asking for the mean, so I'm not going to bother doing an FX column. I don't need to sum them all up. I've got median. Alright, well the median needs a CF column. I could write them all out, but I really don't want to. The only reason we did a CF column was to either make our cumulative frequency polygon, which was still to find the median, or to manually find the median. But CF had to do with median. So let's do our CF column. So far we've got a frequency of 4, plus 6 more makes 10, plus 3 more makes 13, plus 3 more makes 13, plus 3 makes, I didn't actually add it, plus 3 more makes 19, plus 1 makes 20. Let's also add these up. 3 3 is 9, plus 1, 10. Yeah, that will always happen. Your sum of your frequency column should equal the last number in your CF column, because there's 20 scores, so that's telling us where we're up to. Now, what's the median quiz score? Well, I know if I say there's an even number of digits, like I hold up both hands, I know for my 10 fingers, the 5th and 6th fingers are in the middle. So it's halfway in the next one. Half of 20. I want to know what's the 10th score and what's the 11th score. Well, if I put a line here, that tells me the 10th score was a 1. After 11th, 12th and 13th scores are all 2s. So the median is halfway between 1 and 2, which is 1.5. The mode is just the one that occurred most often. What's the highest frequency? 6. 1 happened 6 times, so the mode is 1 because it happened more than any other score. And the range of the quiz scores is just highest minus lowest. The highest quiz score, someone got 5 out of 5, someone got 0 out of 5. So the range is 5 minus 0, which is 5. Come on, move down a bit, please. Page down. Adam did 3 assignments for EPMATH234. The class results and Adam results are shown below. Okay, mean of the class and standard deviation of the class, and then Adam's results are here at the end. So when did he perform best, in which assignment? It may not say Z score, but that's what Z scores are for. Z scores compared our performance to the overall group doing it. It used the mean of the group and the standard deviation of the group to tell us how good our individual result was. Now, the Z scores are worked out by saying the score you got minus the mean of everybody over the standard deviation of everybody. So let's do that. Let's put a Z score at the Z score column at the end. So the first thing I'm going to do I'm going to run out of room, but Z1 equals, for assignment 1, the score Adam got was 19, minus the mean of the group was 18, and the standard deviation was 0.9. I'm going to get a trusty calculator here. So 19 minus 18, that's 1 divided by 0.9. What is 1 divided by 0.9? It's 1.1 repeater. So 1.111, whatever, 1.1 with a dot above it, 1.1 repeater. Now the next thing would be, now Adam's result is still 19, but the mean is 16.5, and the standard deviation is 2.1. 19 minus 16.5 is 2.5 divided by 2.1. It's going to be close. It's 1.19 to 2 dp. 1.19, I've just rounded that to 2 dp. Okay, that's the best so far. What about assignment 3? Running out of room there. Z score for assignment 3. It's his score of 19 minus the mean of 15 over a standard deviation of 3. That's 4 on 3. That's 1 1/3, which is 1.3 repeater. That's the best. Yep. His highest Z score was in assignment 3, which is C. The sales per day of a certain type of phone were recorded for 1 week. So we've got 7 results, okay, for each day of a week. Which of the following measures is the largest for this data? Well, we're going to have to work them all out, aren't we? Are they in order? 7, 9, 9, 10? Yes, they are. So I'm going to do the range first. That's easiest. Highest minus lowest. 15 minus 7 is 8. What about the mode? Well, there's 2 9s. Nothing else happened twice. The mode is 9. The median, well, they're in order, so let's just walk our way in the middle. 3 to the left, 3 to the right. The median is 10. We're getting bigger. What's the mean? Well, I'll just add them all up. I'll be lazy. 7 plus 9 plus 9 plus 10 plus 13 plus 14 plus 15 equals 77 divided by 7 equals, the sum of them was 77. There were 7 of them. 77 on 7 is 11. The mean was the largest. The following stats are obtained from a class in maths and science tests. Okay, that mean, that standard deviation. What mark in maths would be equivalent to a mark of 77 in science? Equivalent performance in subjects, again, it's got to be talking Z scores. So let's look at what's a Z score for a mark of 77 in science. Z score for science is equal to, we said it's the score we're discussing, 77, minus the mean, which is 62, over the standard deviation, which is 6. We used all of science as data. 77 minus 62, well, that's 15 over a 6, which is 2.5. Okay, so that's a Z score of 2.5. That's a brilliant result. We want to say, well, okay, perform that brilliantly, perform equivalently in maths. Now I could use the formula, or I'd rather use just the definition of Z score. If I want to get a Z score in maths also equal to 2.5, that literally means I'm going to need to score 2.5 standard deviations above the mean. What's 2.5 fours? 4 plus 4 is 8, plus a half of it is 10. I need to score 10 marks above 65, which is 75. I could have used the formula. The formula said Z equals X minus X bar on standard deviation. Alright, well, we're trying to get a Z score of 2.5 equals X is, I don't know what score yet, minus the mean in maths was 65 over the standard deviation in maths was 4. Alright, we've got an equation. I can't add 65 to both sides because that minus, that's all trapped up in the top of a fraction. But I can get rid of this divide 4 here by timesing both sides by 4. 4 times 2.5 is 10, and 4 times the right, and I just lose the denominator. Now I get rid of minus 65 by adding 65 to both sides, and if I add a 65 to that 10, same answer, 75 equals X. 28 for 2 sets of scores. Well, this will be a bit dull. Calculator exercise, well, you sit here and listen to it. But we consider, do they have the same mean? Do they have the same standard deviation? So I've just got to go in and do it. From memory, they were the same. I'll go in, mode, stat, single variable. And I'm going to put in a 4, 6, 7, 17, 18, and a 20. And all clear. I'm going to go into my stats for variance and ask what the mean is, and it says the mean is 12. I'm also going to ask it what the standard deviation was, and it says standard deviation on my calculator, it's this sigma x thing, and it says it's 6.45497 blah 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 blah. Now I'm just going to jump out of stats mode and jump back in again. Single variable, we go 2, 8, 9, 15, 16 and 22. All clear, and my mean, it says, is 12, and my standard deviation, it says, is, surprise surprise, 6.4549 blah blah blah. Clearly they're both the same. So both of these statements are correct. Yep, same. 29, the mean weight of 500 packets of M&Ms is 250 grams with a standard deviation of that. Okay, we're talking about percentages. 95% of the packets. I can see this is talking about this normal distribution curve. Okay, so we've got the percentages. I know in the middle lies the mean, which is 250 grams. Standard deviation of 2.4 means we're jumping up 2.4s. So 250 plus another 2.4 is 252.4. Now how far do I want to go? It's asked me about 95% of the packets. And I know that 68% was how much lay between plus or minus 1 standard deviation of the mean. 95 is my next magic number between plus or minus 2 standard deviations. 99.7% was plus or minus 3. So there's my answer. I don't need to draw the whole picture. I just need to know that 95% of my results will lie within 2 standard deviations of the mean. If 1 standard deviation is 2.4, 2 standard deviations is 4.8. So I just need to think, what's 250 plus 4.8? Well, that's 254.8. What's 250 minus 4.8? And that would be 245.2. And where's that? 245.2 grams, 254.8 grams. That's both 2 standard deviations up and down from the mean. Yoink. Now Skylar got a Z score of 2, increased 5. Skylar's result was, this is just a pure conceptual understanding, and we already did one of these. I said before we had a Z score of 2.5, and that literally meant I could jump 2.5 standard deviations above the mean. So Z score of 2 is not 2 marks, doesn't talk about marks, it's 2 standard deviations, not above the median, no. 2 standard deviations above the mean. That's the definition of a Z score. Yep. Now to the written section. Complete the table of values for the equation. Well, these are all in columns, so it's like saying when x is minus 4. So I go y equals minus 2 plus x on 2, well that's a minus 4 on 2. And minus 4 on 2 is a minus 2. Minus 2 plus a minus 2 is a minus 4. A plus and a minus combined make a minus, so it's minus 2, which is minus 4. Or we can just go for the calc, but either way, that's what happens. If that had been a minus 2 in there, minus 2 on 2 would have been a minus 1. A minus 2 minus 1 would have been a minus 3. If I put a naught into here, minus 2 plus naught divided by 2 is, naught divided by 2 is naught. I can see the trend. Put a 2 in there, it's minus 2 plus 2 on 2, minus 2 plus 1, which is minus 1. Put a 4 in there, 4 on 2 is a 2, minus 2 plus 2 is a naught. Alright, let's plot those points. Better go down a bit. Minus 4 on the x and minus 4 on the y. There's the first point. Minus 2 on the x and minus 3 on the y. Got it. Naught horizontally, but minus 2. Got it. 2 on the x and minus 1 on the y. Got it. 4 on the x and naught in the y. Got it. And I'm never good with this ruler, but I'm going to try. And go... No, it's not. Ooh. Not bad. Alright. Graphed. Find the equation line with y-intercept 6. In other words, b equals 6, which passes through the point minus 4, 5. So the bits of info I've been told here is I know the y-intercept. I know an x value that works, minus 4, when the y value is 5. I know when it said find the equation, I'm thinking y equals mx plus b. And all I need to do is replace the m with the gradient and the b with the y-intercept. Well, easy to replace the b with the y-intercept because the y-intercept is 6. I still need to know the m, but what I can do now is I've got a point I can sub in. I know that when x equals minus 4, when it's m times minus 4, I know that y equals 5. So what have I got? 5 equals m by minus 4, or rather like minus 4m, plus a 6. Let's get rid of, I want to get that m by itself. Easiest thing to get rid of, let's get rid of that plus 6 by minusing 6. 5 minus 6 is a minus 1. Covered. Okay, and then let's get rid of that. At the moment that m is being times by a minus 4. Let's divide it by minus 4 so I can get rid of it. As long as I do it to both sides, that's cool. M equals a minus 1 on a minus 4. well, calculate or confirm what I'm saying, but a minus on a minus makes a plus. Gradient's a quarter. So don't forget to rewrite it. We found the gradient, we knew the y-intercept, but I've got to find the equation of the line. I've just got to rewrite y equals mx plus b, but instead of the m, put the gradient, instead of the b, put the 6. Great. Find the gradient, y-intercept, and the equation for the following graph. Well, I'm going to go for the easy one first. The y-intercept, or in this case, technically you could call it a q-intercept, is 500. Alright, easy enough. The gradient, I want to lock in a minus straight away. Clearly it's going downhill left to right. Now, where's some nice points? There, I could say, let's just do this whole big one. It's clearly passing through there and there. So it's gone down 200. So it's the vertical rise is actually a 200 drop from there to there over a run of 40. So yes, it's minus. We've already locked in that. What's 20 on 4? 5. The gradient's actually minus 5. And so the equation, instead of writing y, I'll write q equals m is a minus 5. Instead of writing x, it's a t plus b. There's the equation of the line. Convert this equation to the form y equals mx plus b. Okay, and then we're going to use that form to answer some questions. Well, first I want to get y equals. Now do I want to chuck the 12x and the 8 over and leave the minus 3y? Or, I'd rather chuck the minus 3y. I'd rather add 3y to both sides because I want a positive 3y anyway. Let's leave the 12x there. Let's leave the plus 8 there, but add 3y to both sides and go, oh, nice. I might want to swap left and right. That's okay. If right equals left, left equals right. But clearly I still want y equals, so I better divide by 3. Okay. 3y on 3 is just a y, 12x on 3 is a 4x, and 8/3, well, it doesn't really simplify. I could call it 2 2/3 if you want, but there's nothing wrong with writing plus 8/3, done. So for this line above, the gradient was the 4. The gradient's always multiplying the x. Remember, the gradient isn't 4x. The gradient is the number times the x. And the y-intercept is whatever number was without the x. I don't have to write the plus, but I know it's a positive 8/3. 6 young adults were surveyed to find the number of hours, water, that they spend doing exercise each week. This is compared to their blood cholesterol level. So we've got period of exercise, E in hours, okay. So they're the X values, and then blood cholesterol level, they're the Y values effectively. So let's just plot some dots. Right. On the E axis, otherwise known as X, goes 6 and then up 5. There's 6 and there's up 5. Alright, there's a point. Then it's 8, 4.5, so 8, 4.5, well there's 4, there's 5, 4.5 will be there. 12 and 3, so go to 12, we go up to 3. 16 and 2, 16 and 2. 2 and 7.5, 2 and 7.5. And 5 and 6. 5 is here and 6 is here. Alright, now we're all going to get different lines for the next bit. Okay, that's okay. I'm going to draw a line about, yeah, that looks good to me. The ruler moved again. Look, we'll live with it. This is not, rocket science, this one, or that's not the same. I mean, brain surgery, we don't have to be that careful. Look, let's pretend it's a straight line and the ruler didn't move. It's a shit line though, hang on. I'm going to do that again. It don't move. I'm going to go through okay, there's one of them. There we go. That's it. I'm sticking to it. So graph this data, done. Draw a line of best fit, done. And trust me, if the line was, very different to that, look, as long as it's roughly going through the little points, it's all good. I want to know the gradient of my line of best fit. Okay, well, I'm just going to pick the endpoints. So I'm going to say that vertically, well, I've gone from, where are we? I'll use the formula, just to practice the formula too. You can just draw a triangle under if you want, but I'll use the formula and I'll quote these points. This point is x of 0, comma, what's that about? If that's 1, and it's put into 5 bits, that's 0.2, 0.2, 0.4, 0.6, 0.8. So I reckon that's about 7.6. I reckon this other point is 16, comma, I reckon I'm right halfway in between, 1.5. So I reckon that dot fell. So, and I'm going to call you x1, y1, and you can be x2, y2. So I've got a 1.5 minus a 7.6 over a 16 minus a 0, which is, I'm just going to the calculator now, 1.5 minus 7.6. It's a minus 6.1 divided by a 16. So what did I say? Minus 6.1 divided by 16 equals minus 0. I've got 61 on 160. I can leave as a fraction or a decimal. It doesn't matter. Some of these will be. I'm just doing that. That was my answer. Minus 0.38125. That'll do. Find the equation of a line best fit in terms of C and D. Right here. I know as soon as it says equation of a line, y equals mx plus b. But I'm going to replace the y with, it's a c-axis. I'm going to replace the x with, it's an e-axis. The gradient is minus 0.38125. And my y-intercept was 7.6. Okay, that's not the neatest thing I've ever done. It's not the worst either. C equals minus 0.38125, E plus 7.6. Steve is a golf player. Good on Steve. And his scores on his last 48 games in his golf course are listed below. So I'm just going to check. Make sure there's no errors. 10, 19, 48. Yep, it's true. Steve's about to play another game on the golf course. What's the experimental probability that Steve's score will be lower than 94? That's talking about these. Okay, lower than 94. That happened 4 times out of his 48 games. Yep, that'll do. Or divide top and bottom by 4, could be a 12. Higher than 93? Well, that's everything else. Everything else here is higher than 93. So I can add them all up, or just know that it's the rest of the games, it's a 44 and 48. That's what it'll add up to. Or I can call 11 or 12. Okay? So I can either do 1 minus the answer we already had, or just add them up. Higher than 109? Well, his experimental probability, we're not saying it's impossible to happen, but his experimental probability says he never got higher than 109. So it's got an experimental probability of 0. It doesn't happen. Based on the scores recorded above, how many times can Steve expect to score in the range 106 to 109 on his next 18 games on the course? Well, that's expectation. An expectation is the number of times you do the experiment times the probability. The number of times we're going to do this experiment is 18 more games. The experimental probability of getting in the range 106 to 109 was, if I roll up a bit, was 8 out of the 48. So times 8 on the 48. I can see that there's 1 8 there and 6 8 to 48. It's an 18 times a sixth, which is a nice whole number. 3 times is what I'd expect. In a class of 30 students, okay, we've got another Venn diagram. 15 students study mathematics, well I can't put that in there. 24 study science, can't put in that, but 3 students study neither, I can do that. Okay, complete the Venn diagram. Well, it said a class of 30 students. So I'm going to note that how many can I fit in my circle thing? I need to fit 27 in there, maximum. But we're told 15 study maths and 24 study science. So that adds up to 39. And again, the gap between what must fit in there and what I'm trying to fit in there must be those that answered both. Here the gap is 12, so 12 people must have been part of the 15 that said yes to maths and part of the 24 that said yes to science. Hence, if the 15 students study mathematics, if 12 of them did both, 3 must make it to 15. If 24 chose science, and there's already 12 here, that means 12. So if I got 15 in my M circle, I do. If I got 24 in my S circle, I do. And what do they add up to? 24 plus 3 is 30. Gold. Find the probability that a student chosen at random from this class studies maths only. Well, that's only 3 people. Only 3 people studied maths only, and it says probability, not number. My answer is not 3, it's 3 student chosen at random from this class. How many were there? 30. 3 of these students out of the 30 studied mathematics only, or a tenth if you want. Mathematics or science, well, remember we use that inclusive or. We say mathematics or science means one or the other or both. It's all of this. All of these people study maths or science. which is everyone but 3. It's 27. Or just add those 3, but it's 27 out of 30. We can call it 9/10 if we want. Do as you feel. Okay, be careful of this one, but just read it carefully. It says, what's the probability of choosing a student at random from this class, and the probability they study science, given that they study mathematics? As soon as it says, given that they study mathematics, means I'm already telling you that the person I talk to studied maths. And there's 15 people that study maths. So out of those 15 people, what's the probability of selecting someone that studies science? Well, 12 of those 15 also study science. There's my probability. There's 4 3s there and there's 5 3s there, so I could do that simplification if I want. Okay. A barrel of apples contains a mixture of red and greens, however not all the apples are edible because some of them are rotten. Fine. Reds, greens, rotten, not rotten. If an apple is chosen at random, what is the probability the apple is green and not rotten? Green, here, not rotten here. 30, but it says probability. So it's got to be 30 of those apples out of how many? Let's just add some totals columns. I sense we'll need them anyway. 5 and 10 is 15. 20 and 30 is 50. 5 and 20 is 25. 10 and 30 is 40. 25 and 40 is 65, as is 15 and 50. So yep, 65 is the grand total here of people in this survey. Or this, sorry, not people in the survey, of this barrel of apples that was sampled. Fine. 3165 is a perfect answer, but I can say, well, how many 5s are in U and how many 5s are in U. Doesn't matter which form of the answer you go for. If an apple is chosen at random, what's the probability that the apple is red? Okay, well again, we're just choosing an apple at random out of the 65, and how many of them are red? 25 of them were red. Didn't care whether they were rotten or not. 25 were red. And that can simplify down to 5 on 13. 5 5s up top, 13 5s down the bottom. C says if I choose a green apple, okay, what's the probability that's rotten? So we're told that I'm choosing a green apple, and there's only 40 green apples. So it's out of 40. How many of those 40 green apples were rotten? 10 of them. 10 on 40. That's an easy simplification. Divide top and bottom by 10. The answer's a quarter. Next, a bag contains 5 red marbles and 7 blue marbles. 5, that's a hat, okay. 5 red, 7 blue. A bag, that'll do. The first one is not replaced while the second marble is selected, so let's do the tree diagram. Now I don't want to do 12 arms for the 5 reds and 7. I'm just going to do 2 arms. The only outcomes are red or blue, but yes, they're weighted. As in, there's 12 items in there, 12 marbles, 5 of them are red. So I've got a 5 in 12 chance of getting a red and a 7 in 12 chance of getting blue. And I'll just do a check. Do they add up to 1? Yeah, 5 12ths and 7 12ths is 12 12ths. It's all good. Now, after picking a red apple, stop saying a red marble. I again could go red or blue. So this is saying I did pick a red marble and I did not replace it. So there's only 4 red marbles now out of a total of 11 marbles. Yet there are still 7 untouched blue marbles in the bag out of the 11. And again, I check, and 4 11ths plus 7 11ths is 11 11ths, which is 1. It's perfect. What if I had actually picked a blue marble first? Well, I had 7 blue marbles out of 12, so if I pick a blue marble, I would now only have 6 out of 11. Yet the original 5 red marbles would still exist. I didn't take a red marble out, so it'd be 5 out of 11. And add them up again, and 5 11ths plus 6 11ths is 11 11ths. Perfect. I'm going to write the whole thing out. It's over the top a bit, but I'm going to do my sample space. I could get red, 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 black, black, red, black, black. Red, red is this happening and this happening. We know and is the time, so it's 4 by 5 on top, it's 20. And 11 12s is 132. 5 7s is 35 on 132. 7 5s is still 35 on 132. And 7 6s is 42 on 132. If you add up a 20, a 35 and a 35, well that's 90 plus 42 is 132. Even all these add up to 132, 132, which yet another check that it added up to 1. So the probability of selecting 2 marbles was this option, 42 on 132. I'm not going to bother simplifying it, I just don't want to. Find the probability of selecting a marble of each colour. Well, each colour means red, blue, or blue, red. It's that or that. We just add them. Okay, and is the times, we times across the arms, but this or this, the probability increases if you've got an or in there, you add them. 35 on 132 plus another 35 on 132 would be 70 on 132. And the probability of selecting at most one red marble means don't go more than that. You can have as many blues as you want, but at most you're allowed one red marble, which is, you can't have two red marbles. It's everything else but two red marbles. So again, whatever you feel, either add those three options up, which is 35 and 35, 70, plus 42, which is 112, out of the 132. Or I could have said, it's 1 minus the only option that isn't allowed, that doesn't satisfy the question, which is still going to give me 112 on 132. 10. A manufacturer tested a batch of batteries to determine the number of hours which the batteries will continuously operate the chosen toy. Okay, got 30 batteries. Let's find out. Okay, this is a bit backwards. Normally we have the data and then we make the histogram, but we're going backwards here to show our understanding of the histogram. So what was the life of batteries we had? The lowest life was 5, the highest was 12. 5, 6, 7, 8, 9, 10, 11, 12. The number of batteries that did it, well, that's the F, the frequency of each. 1 battery, then 2, then 4, then 9, then 6, then 5, then 2, then 1. I want to add these up and check that I've got all 30. Got 3, 4 is 7, got 16, got 22, got 27, 28, 29, 30. And let's do the FX column. Okay, I've got one lot of 5 hours, which is 5, 2 6s is 12, 4 7s is 28, 9 8s is 72, 6 9s 54, 5 10s, 2 11s and 1 12. Now let's add them up. 4, 8, 10, 25, 2, 3, 4, 5, 10, 22, 24, 25. Okay. Then it says use the formula for the mean of a distribution of scores. We've already done that. We said mean was the sum of the FX column, in other words, all the scores added up, yoink, divided by the sum of the F column, which is how many scores there were. There's 30, remember there's not one of each one, there's multiples. So it's saying the sum of all the scores is 255 and the number of scores is 30. What's 255? Turn the calculator on. What's 255 divided by 30? And actually it was a nice answer of 8.5. But I should write its units, enough hours. Does that seem about right? They went from 5 to 12, 8.5. Yeah, that seems quite reasonable. I'm not questioning it. Now 30 students were surveyed about their weekly income in dollars with the results shown. Okay. Alright. Use this data to complete the frequency distribution table. So let's look. We've got, okay, all the categories from 0 to less than 40. I just average the ends to find the class centre. In other words, 0 plus 40 is 40, divided by 2 is 20. Or just think of the number halfway between a 40 and 80 is a 60. Halfway between them is 100. Or again, add them if you want, call it 280, but halve it, 140. Also, you'll note these are all jumping up by 40, plus 40, plus 40. Oops. Alright, they're my class centres. The tally, well, let's do the column. I've got a 30 goes here, and a 190 goes here, and a 160. Note the 160 doesn't go here to the less than 160. The 160 goes here. That's the class 160 to less than 200. A 37 in there and a 185 in here. 54, 25, 78. 54, 25, 78. 68 and a 180. 81, 38, 57, 120, 162, 154, 80, 62, 29, 128, 134, 51, 123, 78, 130, 38, 42, 49, 10, 1, 4, 5. So we've got a 7 count, a 9, a 2, a 7 and a 5. Let's add them up. 12, 14, 23, 30. Yes, it said 30 students. 1, 2, 3, 4. There's a 5 by 6. we're all good. Cumulative frequency is how many have we got? It's like those zigzags. So far we've got 7, plus another 9 makes 16, plus another 2 makes 18, plus 7 makes 25, and plus 5 makes 30. There's another one of my checks. The last CF number is the same as the total of the F column. And F times CC is like the FX column, but I don't actually have scores, I've got classes. So I say how many of the class center. We're assuming that, okay, there might be 7 scores here, but they're all, let's pretend they're all about the size of 20. So 7 times 20 is 140. 9 times 60 is 540. 2 times 100 is 200. 7 times 140 would be 980. Just checking that because it's a 700 and a 280, yep. And 5 times 180, that would be 900. Add all of these up, I've got noughts and 16 and 19, 21, 22, 27. So what's the modal class? Well, what happened the most? 9 was highest frequency, which was the 40 to less than 80 income bracket. What's the median class? Well, there's 30 scores, as we said before, for an even number of scores. Oh no, what's the 15th and the 16th? And the cumulative frequency column says they're both here. The 15th and 16th are all in the 40 to less than 80. And then find an estimate for the mean weekly student income. It says estimate. It means don't go back to the raw data. I could find the actual mean by doing the raw data up here. It means use the table to find an estimate. And it's the mean is, instead of sum of fx column, the only difference for this is sum of f times the cc column over the number of scores, which is sum of the f. The f times cc column added up to 2760, assuming all the scores were in the middle of the class. The number of scores was 30. Let's do that. And 276 divided by 3, well, that looks like a 92 to me. So that's an estimate for the mean. I should put dollars at $92. And again, I checked, is that around the middle? Yeah, we're looking good. Okay, we've got a cumulative frequency histogram done. Now we want to put the ogive on it. Well, okay, the ogive is going from bottom corner to the top of the next, and then, well, it's got to go flat, and then this isn't going to work out as much as neat as I'd like it. Oh God. Now it's not even going to draw for me. And then, okay, budget, but yep. Use your graph to estimate the median. Well, the median's a middle score. These scores don't go up to 70, the scores only go up to here, 60. So the middle score is a 30th score. You could say, hang on, don't you mean the 30th and the 31st? Yeah, I do, but look, it's an estimate. I could look for the 30th and the 31st score, but the difference is so negligible. I'm just choosing 30, okay? And then until you hit the ogive. Okay, so now I've got to do an estimate. That's 75 hit. This looks like 73 to me. Yep. The estimated median is about 73. For the following data, what's the range of the data? Well, I've got a 1, 2, 3, 4, 10. 1 and 10 is the highest and lowest. 10 minus 1 is 9. What's the mean of the data? Well, I better add them up. 4 and 3, 7, 8, 9, 10. They add up to 20. And there's 1, 2, 3, 4, 5 scores. So the mean is 4. Complete the following table. Well, that starts off, it's for the same data, 1, 2, 3, 4, 10. First column tells me to take the mean off each data. What is the mean? 4. 1 minus 4 is minus 3. 2 minus 4 is minus 2. 3 minus 4 is minus 1. 4 minus 4 is 0. And 10 minus 4 is 6. Next column is the same heading as the previous, but it says square it. Well, minus 3 times itself is 9. Minus 2 times minus 2 is a plus 4. And we just square everything. I've got a box here for me to add them all up, which becomes 50. And then it says use that table to find the standard deviation of the data. Well, you could have looked at it a few ways, but I know on our data sheet it tells me that the standard deviation is the square root of the sum of the x minus x bar squared column over n. The sum of the x minus x bar, I can't speak. the sum of the x minus x bar squared column is that. That is the sum of this column. The number of scores, well, there was only 5 scores, so that's a root 10. To one decimal place, go to the trusty calc, root 10 is 3.16. So the 1/6 runs it up to a 3.2 to 1 dp. Done. Nearly there. The breakfast cereal company determined the mean weight of their cereal boxes was 646. I'm going to start drawing a picture already. I could have left myself more room. Okay, the mean is 646. The standard deviation is 4. So I'm going to go up by 4 to 650, up by 4 to 654, and up by 4 to 658. I'm also going to go down by 4s to 642, and 638, and 634. What percentage of boxes would you expect to contain between 646 and 654? 646 and 654, it's all of this region. And if I've remembered my percentages, well, I know in the resource sheet tells me, or the data sheet tells me 68% lay between here and here, so that's 34 each. And you'll see in the lecture notes we did the other sums where we said what's 95 minus 68, and then we halved it, we got a 13.5% sitting in here. We did the same stuff, see lecture, to get a 2.35% here and a 0.15 left in these tiny little things at the end. They're all percentages. So between here and here for question A, 34 plus a 13.5, that's 47.5%. I just added the 34 and the 13.5. Then what percentage of boxes will contain more than 654? So question B is from here onwards. Well, that's just adding up these two numbers. 2.35 and 0.15 is 2.5%. The next one talks about they're trying to guarantee 638 grams of cereal. So it's here. And if it's less than this amount, well, that's what we're being asked. How many people are going to get ripped off? Well, I can see it's 2.5%. It's symmetrical to the other answer we got, but it says how many boxes. So it's 2.5% of what? Well, 2.5% means 2.5 per 100. You might use your percent key, but I just treat percent as over 100. 2.5% times, well, how many boxes? They produce 5,000 per day. So there, I've just got to go to my calc, go 2.5 divide by 100, and then times by my 5,000. And it'll tell me there's 125 boxes a day likely to be underweight. Now I've got in an English exam, the mean mark was 75 and the standard deviation was 4. What were the Z scores? We've already played with the Z score formula. We said Z score was Z was equal to score minus the mean over the standard deviation. So if the score was 67 minus a mean of 75 over a standard deviation of 4, 67 minus 75, well, that's got to be minus 8 on 4. And minus 8, that's a minus 2. He scored 2 standard deviations below the mean. Yeah, he scored 2 4s below 75. The next person, I could already see the answer. If the mean was 75 and he got 75, his Z score is 0. Okay? If you want to prove it, well, Z score is a score he got of 75 minus the mean of 75 on a 4, which is a 0 on 4, which, as I said, yeah, it's a 0. Now, there's marks from a test are normally distributed with a mean of 62 and a standard deviation of 6. A student got a Z score of minus 2.5. Similar to one we've done before. I could either do it manually. I know the definition of Z score means how many standard deviations you were above or below the mean. This minus 2.5 means that's 2.5 standard deviations below the mean. What is 2.5 sixes? 2 sixes is 12, plus half 6 is 3. That's 15 marks below the mean. That's what this bloke got. 62 minus 15 would be 52, would be 47. That's me working out that way. What was their actual mark? 47. But I better show some working because it's 2 marker. Some working I can do is just Z equals X minus X bar over standard deviation. Let's sub things in. A Z score of minus 2.5 is equal to the score they got minus the mean of 62 on the standard deviation of 6. We did this before. We said the minus 62 was trapped up here, so let's get rid of this divide by 6 by timesing by 6. 6 times minus 2.5 is minus 15. Sounds like what we did before. And then to get rid of this minus 62, because I want the x by itself, I've got to add a 62. Add a 62 to a minus 15, and we'll get 47 equals x, which is what we already said. Great. All the best with it, and I hope that was fun. See ya.